Hello everyone, this is Siddharaj and Akshit Jain. Here we are going to discuss DC to DC boost converter, its explanation, and also its MATLAB simulation. A boost converter is generally a step-up converter, is a DC to DC power converter with an output voltage greater than its input voltage. It is an SMPS class, which is a switch mode power supply containing two semiconductors, a diode and a transistor, and at least one energy storing element, capacitor or inductor, or the combination of both. Uh, this is the circuit diagram that we are going to simulate and also explain. It is a bit different from other boost converter as we have included parasitic resistance in the passive component, and there is an on-state resistance in the active component. Like, for understanding the explanation and working of this boost converter, we are going to refer this circuit. In this circuit, DC input shown. It is of many types such as batteries or from fuel cells, solar panels, dynamos, or DC generator. So the boost converter is different as its output voltage is equal or greater than its input voltage. Therefore, it is important to remember that as the power is equal to voltage into current, if the output voltage is increased, the output voltage current must be decreased. So basically we need to decrease the current value of the current, and this is done. We can see this is a MOSFET switch. This is an inductor. We have taken one more resistor in our simulation circuit, that is for the passive elements. This is the diode, capacitor, and output resistive load. And we are giving a square wave as the input, and what we need to get is output is greater than the input. So during the initial high period of high frequency, square wave applied to the MOSFET gate at the startup. During this time, MOSFET conducts, and this is showing the short circuit path. The energy is stored in the inductor. We are seeing that current is following this path because the diode D1 and the C1 circuit, also a load, has a high impedance comparing to this MOSFET gate. So this is the current path shown here. Now during the low period of the switching square wave, MOSFET is rapidly turned off. As you can see, there is a sudden drop across L1 and it produces a back EMF. So the EMF across this, that is a back EMF, and the input EMF which we are providing, input voltage, together they contribute the current to the diode D1, which is forward bias, and this charges the capacitor, and also some current flows through the load. So the capacitor is charged, as shown the polarity here, positive is here, and with the magnitude of VL and Vin, negative. Now again during the positive half cycle, this MOSFET start conducting. Diode is again in a conducting as it is in off state. We can see because there's a negative here and positive here as back EMF of the, and the charge that is present on the capacitor, that is my negative of VL plus Vin, is now given to the load. Therefore, we can see that the voltage given to the load VL plus Vin is higher than Vin, and thus this is how a boost converter works. And again, during the negative half cycle, capacitor again charges to the same voltage VL plus Vin, and during the positive half cycle, it is given back to the load. So this is how boost converter works. Now we are going to simulate this circuit on MATLAB. First, I need to get the Simulink, new Simulink, which I get from here. From the new Simulink, commonly used block, I need to click. Then I need three inputs, three output, one output, that is scope, and one is a subsystem. In the subsystem, I will design my boost converter, and then I will mask it. So three inputs I will select. After selecting all the above, my circuit will look like this. I have renamed the input sources here. One is input voltage VG, another one is duty cycle, another one is load current, Iout. This is the scope where we are going to see the DC boost output, and this is actually this one is a boost converter. Here we are going to design internal. This is a subsystem. We are going to design a full boost converter in this circuit, a full boost converter circuit in this subsystem. And for designing this boost system, I need to double click this sub. Now you see there is a default connection between the input 1 and output 1. Delete this connection. Add two more inputs from here, and three more outputs we need to use. And in the subsystem we need to use mux and demux, which are also found in this. This is mux, this is demux. And we need to use a MATLAB function, and MATLAB function we'll get from this user defined function. Here I'll get a MATLAB function. This I need to insert one, and two more integrators I need to insert, which I'll get from the continuous library. Continuous. These are the two more integrators. So, and I need to make the connection, and also I need to change the input of a mux to 5 and the output of demux to 5. So my circuit will finally look like this. This is how I have made the connection. This is a subsystem block. These are the integrators I have connected. These are the four outputs. This is three inputs, and this is a PWM system. This system block, PWM system block, I need to double click it and remove the default connection between the input and the output. I need to add one repeating sequence block, which is found under the source. This is the repeating sequence block I need to add. Then another thing I need to add is subtract block, which we can found in a math library. This thing we need to add one subtract block. This is the subtract block. And finally, from the discontinuous library, I need to add one relay block, and this is the discontinuous library. From this I need to add one relay block. This is the relay block, and the connections are made shown in this figure. So this is how I need to connect all the components. Now double click on this repeating sequence block and give the values as I have given, like 0 and 1.0 divided by fs, and this is 0 and vm. These are the values which I need to be given to the repeating sequence block. Now from that working which we have discussed earlier, we will get these equations. When MOSFET is on, the above equations are derived. These are the equations which are derived from the circuit that we have shown before the simulation, and these are the input voltages. In terms of the input, I have derived these equations, and similarly when the MOSFET switch is off, the equations are given by this. Now after one switching period Ts, the equation can be combined and represented as follows. This is the equation of the inductor voltage VL, and for the capacitor current IC, this is the equation, and input current is this. Output voltage V is given by the equation. Solving the equation and simplifying, we'll get all the equation of the input in terms of these outputs, and these equations now we are going to simulate on the MATLAB, and we are going to put that in the MATLAB function. So first we need to go to the subsystem, and there we need to write a MATLAB function, MATLAB program, and the MATLAB program which we need to write is shown below. So this is the MATLAB function that I have written. This is the input. U, L, C, R, L, R1 and RES, these are the inputs. Y is the output of that MATLAB function subsystem. So this is the program. These are the input. This is the input voltage, switch control, load current, capacitor voltage, inductor voltage, as they are fed back in the circuit that we have shown. This is the output voltage, input current, capacitor current, and the inductor voltage. the equation that they given. I have written that directly. Now I need to go to the tools, edit data ports. From this, it's showing what I have taken, input, output, and I need to change this to parameters. These are the parameters L, C, RL, RON. This can be changed by selecting like this from the drop down box. Parameter input, I need to select parameter here, and U is the input, Y is the output. Okay, after that I'll close this. Now I will go back to the main subsystem, and I need to determine the initial condition for capacitor and inductor. This is my subsystem. Double click the capacitor. I need to mention the initial condition as 0, and state name I need to mention at VC0, and in case of inductor, initial condition 0, and the state name IL0 I need to mention. Then after this we come back to our main system, and this is the scope. Double click on the scope, as I need to select 4 parallel ports for the scope. Here I have already selected. You need to select the 4 parallel scope, and if you need to mask the components of this boost, you can go to edit marks, and you can mask the components. And finally we are going to set the boost parameters. Double click on it, select these values, as these values are already calculated. Inductance 120 into 10 to the power minus 6, capacitance, inductance, set these values accordingly. Now let us simulate this whole circuit. This is the simulation button, start simulation. This is the snapshot for the output that we have got on the scope. We can see there are 4 outputs, and it is according to the sequence that we have given. That is VC, IL, Vout, then IG. VC is a capacitor voltage output. Vout is actual boost output at the load. IL is a load current, and IG is a source current. So the sequence is VC, IL, Vout, and IG. Now, as we all know that VC is a sum of VI plus VG. So VL plus VG, and this VC will come directly on the output load with a minor resistance drop. Since the input given is 12 volts, and we can see easily that this output voltage is settling at a 30 volts. So thus we are getting boost of 18 volts, and the load current IL, we can see it is settling at around between 2 and 1, and IG, we can see it is also settling between 2 and 1. So thus we can see that voltage boost is around 18 volts, and this is how the DC to DC boost converter circuit works. Thank you for watching this video, and hope it helps you. Thank you very much.